Astronomers have been lying to you about Betelgeuse for the last 4 years. Not maliciously, not to cover anything up, but every time a headline has promised you that the red star on Orion's shoulder is about to explode, somebody in an observatory has quietly looked at the data and known something different, something stranger, something that, until 18 months ago, they couldn't even name. In January of 2026, the Hubble Space Telescope confirmed what a Harvard team had been chasing through the noise for nearly 8 years. And ever since, astronomers haven't been panicking because Betelgeuse is about to blow up tomorrow. They've been quietly panicking for the opposite reason, because it turns out the most famous dying star in the night sky isn't alone, and whatever is happening between Betelgeuse and the thing orbiting it doesn't fit any of the models we wrote down for the last 100 years. This is the story of how one star showed us we understood far less than we thought, and why, when it finally does explode, the show is going to be different from anything we ever pictured. You're going to hear 3 things in the next few minutes. First, what actually happened during the Great Dimming of 2019, the event that made half the world believe the star was dying right in front of our telescopes, and why the official explanation has been rewritten 3 times in 6 years. Second, what Siwarha is, the hidden companion they've just confirmed, and the reason every prediction we ever made about when Betelgeuse will collapse has been built on contaminated math. And third, what would actually happen if that explosion came tonight, or next Tuesday, or one quiet evening while you were sleeping. One of those 3 things you won't see coming. To understand why astronomers have been uncomfortable with this star for years, you need to understand the size of what we're dealing with. Betelgeuse sits roughly 650 light-years from Earth on the left shoulder of Orion. It's a red supergiant. That phrase doesn't really capture it. If you placed Betelgeuse where our Sun is, its surface would swallow Mercury, Venus, Earth, Mars, and stretch out past the orbit of Jupiter. More than 400 million suns would fit inside it. 400 million. It burns with the luminosity of 100,000 suns. But the light you see tonight when you look up at Orion started its journey in the 14th century, before the telescope was invented. Before Columbus. Betelgeuse isn't a star you're seeing. It's a 600-year-old ghost. And like every massive star, it lives fast and dies young. The sun will burn for 10 billion years. Betelgeuse won't make it to one. It has already burned through its hydrogen. It has already burned through its helium. Right now, deep in its core, it is fusing heavier and heavier elements at temperatures of 100 million degrees. In a countdown, nobody can stop, and nobody can fully read. When the core finally runs out of fuel, when there's nothing left to fuse, it will collapse on itself in less than a second. And in that instant, Betelgeuse will become one of the brightest things the sky of planet Earth has seen in the entire time there has been a planet Earth. The question we've been asking for decades is simple: when? And for a long time, we thought we already had the answer. In late 2019, Betelgeuse did something it had never done in the entire span of modern observation. It started going out. This wasn't one of its normal variations. Betelgeuse has always pulsed. Its brightness has always shifted in long, slow rhythms. But this was different. Within weeks, its light dropped to about 40% of what it had been. One of the brightest stars in the night sky, one of the reference points any amateur can find in seconds, dimmed so much that ordinary people noticed it from their backyards. And astronomers in private conversations started saying the thing they had spent decades not saying out loud. This might actually be it. If Betelgeuse was dimming like this, it could be the prelude. Simulations had long suggested that a supergiant in its final months might brighten and darken in strange ways as the core began to lose stability. In the early months of 2020, more than a few theoretical physicists were seriously discussing the possibility that we were watching the beginning of the end. If they were right, the spectacle would be historic. A supernova at 650 light-years would shine as brightly as a full moon, condensed into a single point for weeks. It would be visible in broad daylight. Buildings would cast a second set of shadows at midnight. Anyone alive to see it would remember it for the rest of their lives and tell their grandchildren about it. But the explosion never came. By early 2021, Betelgeuse had returned to normal, and astronomers, after months of analysis, arrived at the strangest conclusion of all. The star wasn't dying. The star had sneezed. What had happened was that Betelgeuse ejected an enormous mass of hot gas from its surface. The gas cooled quickly and condensed into a cloud of dust, and that cloud, sitting directly between us and the star, blocked some of its light for months. We hadn't been watching Betelgeuse fade. We had been watching Betelgeuse through its own veil. That's what got published. That's what most people read. And for a while, the case looked closed. It wasn't. Because there was something inside the data of the Great Dimming that no dust model could fully explain. A pattern. A periodic variation that repeated almost exactly every 6 years, that had been there before the dimming and that was still there afterwards. A secondary heartbeat hidden underneath the noise. And that heartbeat had a shape. The shape of something orbiting. The idea that Betelgeuse might have a companion star wasn't new. It had been quietly circulating in academic circles for decades as a reasonable but unprovable hypothesis. Reasonable because massive stars almost never form alone. They come in pairs, in trios, in entire systems born together from the same cloud. Unprovable because if such a companion existed, it would be too close to Betelgeuse and too drowned by its glare for any telescope on Earth to see. It was like trying to spot a firefly next to a lighthouse 4 million times brighter than the firefly. Until July 2025, when a team at NASA's Ames Research Center, led by Steve Howell, finally pulled it off. They used an instrument called Alapeak on the Gemini North Telescope in Hawaii, a technique known as speckle imaging, where thousands of millisecond exposures are stacked together to cancel out the blurring effect of Earth's atmosphere. And there, right next to Betelgeuse, in an image taken on December 9, 2024, and published the following year, it appeared. A pinprick of light, 6 magnitudes fainter than Betelgeuse, sitting exactly where the models had said it would be if it existed. They named it Siwarha, the Arabic word for her bracelet. The name speaks to the original Arabic name of Betelgeuse, sometimes translated as the hand of the giant, the thing tied to the larger body. But the interesting part of Siwarha, the part that has been keeping half a dozen research teams awake for the last 6 months, isn't its existence, it's its behavior. Siwarha is roughly 1.5 times the mass of our Sun. It's young, genuinely young in cosmic terms, a pre-main sequence star, a stellar infant that hasn't even started fusing hydrogen properly yet. And it orbits Betelgeuse at a distance that, frankly, shouldn't be possible. About 4 astronomical units. That's slightly closer than Jupiter is to the Sun. But Betelgeuse is so colossal that its outer atmosphere, the loose, hot envelope of gas around the star, extends out to where Siwarha is orbiting. Which means Siwarha isn't really orbiting Betelgeuse. It's orbiting inside Betelgeuse, plowing through its outer atmosphere. Every single orbit, once every 5 years and 10 months. Picture a small boat cutting across an ocean of plasma at millions of degrees. Behind it, a wake, a stretched, disturbed corridor of compressed gas that takes months to dissipate. And in January of 2026, Harvard astronomer Andrea Dupree published the Hubble observations that finally confirmed the wake exists, that it can be measured, and that it lines up exactly with the 6-year cycle that has been baffling us for decades. The strange variations of Betelgeuse, the secondary heartbeat that nobody could explain, weren't symptoms of a dying star. They were the scars left behind by a companion carving through it like a knife through butter, once every 6 years. And this is where the story gets uncomfortable. If most of Betelgeuse's strange behavior, the dimming, the brightening, the convulsions of its outer layers, comes from Siwarha's presence, then every prediction we ever made about when this star will explode was built on contaminated data. For years, astronomers calculated the probable date of the supernova by reading the speed and pattern of Betelgeuse's pulsations. The reasoning was clean. A star that pulses faster and more chaotically is closer to core collapse. In 2023, a paper published on Archive suggested on this basis that Betelgeuse might explode not within hundreds of thousands of years, but within tens, generations. Your grandchildren could watch it from a porch. But if what we were measuring was, in part, the gravitational and aerodynamic shoving of a hidden companion, those calculations are corrupted. The star isn't as agitated as we thought. The star is being interfered with. After the confirmation of Siwarha, Howell's team recalculated. The new estimate pushed the explosion window back to somewhere within the next 100,000 years, maybe more. That's what made the headlines. Betelgeuse won't explode anytime soon. False alarm. The astronomers were wrong. But that isn't what astronomers are talking about in private. What they're talking about is this. Siwarha isn't stable. It's spiraling inward. The supergiant is stealing its angular momentum on every pass. The bracelet is tightening. The grip is closing. Morgan McLeod, one of the Harvard astronomers who detected the wake, calculates that Siwarha may merge with Betelgeuse within 9,000 years, possibly less. Other teams working from the same data have suggested even shorter timelines. And the problem is that when Siwarha falls into Betelgeuse, it isn't going to be a clean entry. It's going to be a catastrophic collision that mixes the material of two stars, spins up Betelgeuse's rotation, redistributes its chemistry, and very possibly destabilizes whatever is left of the core. In plain language, the merger could be the trigger of the supernova, and if it is, and this is what nobody wants to say aloud just yet, then the clock that just got reset to 100,000 years might actually be much, much shorter than that. Because we wouldn't be waiting for the core to run out of fuel on its own. We'd be waiting for something to fall in and finish it. That isn't measured in hundreds of thousands of years anymore. That's measured in thousands, or less. Imagine it does. Imagine that tonight, while you're listening to this, somewhere up there in Orion, the core of Betelgeuse finally gives. The first thing to reach us wouldn't be light. It would be a flood of neutrinos, particles so small and so weakly interactive that they can pass straight through entire planets like the matter wasn't even there. Neutrinos would arrive at Earth somewhere between 3 hours and 3 days before the visible light, depending on exactly when the core collapses. This isn't science fiction. There's a global alert system called SNOOZE, designed precisely to catch that warning. Detectors like Super Kamiokande in Japan and the Dune Observatory, now under construction in the United States, are actively listening. The instant any of them registers a neutrino burst consistent with a nearby supernova, an automatic alert sends coordinates to every observatory on the planet within minutes. Every telescope on Earth, professional and amateur, will know where to point before the light gets here. A silent alarm, an hour's head start, maybe more, before the sky changes. When the light finally does arrive, the first thing you'll notice is that Orion has a new star on its shoulder. It will burn with the brightness of a full moon, but condensed into a single point. It will be visible in broad daylight, sitting next to the sun for weeks. At night, you'll be able to read a book by its light if you get far enough from street lamps. It will cast shadows. It will change the color of the world after dark. It will be on every front page, in every news cycle, in every conversation, for months. Then it will start fading. It will take a year, maybe 2, to disappear from the night sky. And when it's gone, one of the most recognizable stars in Orion will simply not exist anymore. The shoulder of the hunter will be empty. Future generations will never know what Orion looked like when Orion was complete. But, and this is what most people get wrong, nothing will happen to Earth. At 650 light-years, a supernova is a spectacle, not a threat. For the radiation from a blast like that to actually be dangerous to life on this planet, the star would need to be within 160 light-years. Betelgeuse is roughly 4 times that distance. The gamma rays, the X-rays, the shock waves, all of it diffuses across the gulf and goes irrelevant long before it gets here. The ozone layer won't notice. Your health won't notice. The satellites won't notice. You'll watch a star die, and not a single dangerous particle will touch you. That's the most astonishing part of it, really. That something this immense, this violent, this absolute, an explosion that for weeks will outshine entire galaxies of 100 billion stars will be, from where you're standing, just a pretty light in the sky. A pretty light you'll watch from a balcony, in the dark, and never quite forget. And here's the part almost nobody tells you. Astronomers aren't panicking because they think Betelgeuse is going to explode tomorrow. They know perfectly well that the odds of it happening on any specific night of your life are vanishingly small. What's getting under their skin is something else. It's that, for the first time in a long time, they don't actually know. They spent decades thinking they understood what they were seeing on Orion's shoulder. Then the great dimming hit and they realized they'd been watching dust where they thought they were watching agony. Then Siwarha was confirmed and they realized the secondary heartbeat of the star wasn't the star at all. It was a companion that had been hiding in the glare for over a century. And now they're realizing that companion is falling, that it's going to collide, and that the collision could rewrite every rule in the textbook. How many other red supergiants up there, the ones that show up in the literature as clean, predictable, well-behaved examples, have a Siwarha of their own that nobody has found yet? Andrea Dupree, the Harvard astronomer who led the Hubble confirmation, said it openly in January 2026. Probably many of them, probably most. Which means almost everything we thought we knew about how massive stars die, about how the heavy elements that make up your body get cooked and scattered, about the timescales on which the universe recycles itself, could be missing a variable we've been overlooking for 100 years. That's what's keeping them up. Not the explosion. It's the possibility that when we finally see it, the event won't look like what we expected, because we were always expecting an ending that was never quite what we thought. Siwarha will become visible from Earth again in November of 2027 when it emerges from behind Betelgeuse. Dozens of teams are already preparing their instruments for that date. They want to nail down its mass with precision, refine its orbit, try to predict how many years are left before the merger, and while they're at it, try to understand what kind of supernova these two stars are going to produce when they finally collapse together. Because it isn't a single star dying anymore, it's two. And nobody with modern instruments has ever watched a system like that come apart. Betelgeuse will still be there tonight when this video ends. If you live in the northern hemisphere, you can still find it. Step outside, look for the belt of Orion, those three stars in a perfect line. Then look up and to the left. There it is, orange, alive, pulsing slowly. The light that will land in your eyes tonight left the surface of Betelgeuse sometime in the 14th century, before the Black Plague burned through Europe, before anyone had imagined the Americas. That light has traveled 650 years across the vacuum to arrive exactly here, exactly now, exactly to you. And inside it, encoded in the patterns of its brightness and its color, is information about a dying supergiant and a hidden companion pulling it toward its end. For all we know, that star already exploded sometime in the last century. The light from that explosion is on its way to us right now. It might arrive a year from now, 100 years from now, 100,000. Nobody knows. The only thing we know for certain is that one day, some ordinary, unremarkable evening, somebody is going to look up at the shoulder of Orion the way you might look up tonight and see something no human being has ever seen this close, with the naked eye. A second moon, cold, vast, in a sky that will never look the same again. It might be you. If this story stayed with you, there's another one waiting on this channel about what lies just beyond the edge of the observable universe. The idea is the same. Spend 20 minutes far from here looking at things we can barely begin to understand. Until then, keep looking up.